Hello, let us have a look about the different types of trees and their properties and their behavior. First of all, whenever we are talking about a binary tree, that means a tree must have one root node and there will be either 0 child of a particular node, either it can be one node or it can be two nodes. That is, either one root can have 0 child, that means this is can be a binary tree, or this can be a binary tree, or this can be a binary tree. So, either a node can have maximum of 2 child, minimum of 0 child, either 0 child, 1 child or 2 child. Left side is called left subtree and right side is called right subtree. At any point of time we can able to have different subtrees. In all subtree there is quite possibilities that this is a node and it is having some childs, this is a left child and this is a right child, this is the root. Then this left child can have again another left child and another right child. In this case, this is a subtree and this is the root now for this subtree, and this is the left subtree and this is the right subtree. So, we have a particular example like this. This is a binary tree where this is a node, it has some childs, this is also child, these are all different childs. Now, if we talk about the properties of binary tree, you will observe if we say the height is, we are calculating the height from 0. Say for example, in a binary tree at 0th height, this is the 0th height, how many nodes are there? If I have a tree with 0 height, we can have only one node, that is 2 to the power 0, that is 1. If we have at height 1, this is height 0, this is height 1. At height 1, how many nodes can be possible? How many maximum number of nodes can be possible? That is 2. This is 1, this is 1. That is 2 to the power 1, that is we are writing 2. At height 2, this is the height 2. Okay, this is the height 2. At this height, how many elements are there? How many nodes are there? There are 4 different nodes. So, we can write 2 to the power 2, that is 4. And this way, if we represent in a full binary tree, if we have how many number of nodes can be possible, how many key values we can able to store in a full binary tree, that is 2 to the power 0 plus 2 to the power 1 plus 2 to the power 2 2 to the power h at height h. So, in this way, if we calculate the formula in mathematics, that is 2 to the power h plus 1 minus 1. Then if we have at height h, what are the elements? So, this is the property. Okay. Now, we have the different types of binary tree. Now, these binary trees type are, first type of binary tree is called strict binary tree. What is strict? Each node can have either 0 child or 2 child. That means, it is not possible like this is a node, this is having only child, this is not a strict binary tree. Either this can have 2 child or this can have 2 child. Here this node having 0 child, but this node having 2 child. So, in case of strict binary tree, each node can have either 0 child or 2 different childs. In case of full binary tree, each node must have exactly 2 child and leaf node must be in the same level. So, this is the example of full binary tree. So, here you can observe this is A, this is full. Okay. So, all the leaf nodes are at same level. In this level, all the leaf nodes are present in this particular level. Now, at either there are 2 childs, this node having 2 different childs, this node having 2 different childs, this node does not have any child. So, this is called strict binary tree. Then comes another type of binary tree, that is called complete binary tree. And what is complete binary tree? The complete binary tree says that at the height, all the leaf node must have at height h or h minus 1, and in this case there will be no missing number in the sequence. What is it? If I have a particular tree like this, if I have a particular tree like this, if I have a particular tree like this, say for example, I am having some sequence like I have inserted element here, then 2 here, then 3 here, then I want to insert here, if I have some element 4 will be here, then 5 will be here, then 6 will be here, like this. Not like that this element is not inserted, this element is not there, I am going to insert 5 here and then 6 here. So, the sequence must not break. In the sequence we have to enter the values. So, at height h or h minus 1, at height h or h minus 1, all the leaf node must be present or there will be no missing number. How is it possible? Like this way, like this way. If we observe this example here you have observed these are the leaf nodes, these are the leaf nodes at height h, all the leaf nodes. Okay. Now, coming to another structure, or this is the structure of binary tree. What is the structure? So, one, we have to declare one structure where there will be two different address, which will, this location will store the address of its left node or its left child, and the right side it will store the right address or address of the right child. This is for the left child and this is for the right child, and this is the data or the key value or whatever values we are going to store. Now, here if we try to define the structure for this, so we will write like this: struct struct, struct, say for example, this is binary tree, I will give some name, then int, I want to store the integer value, this is the data or the value whatever, and there will be two different addresses which are of same type. The type is struct struct bt, this is pointer of left child comma pointer of right child. So, this is the way of representation how we are going to store the or define the template of binary tree. Now, whenever we are talking about the different applications of binary tree where we can use it. So, first application is expression tree in compiler. What is expression tree? If we have some equation like this, a plus b into c, then what is the expression tree? How the compiler, actually this expression tree is used in a particular phase of a compiler. There are different phases are there, like lexic analyzer, syntax analyzer, semantic analyzer. There are different phases in compiler design. Whenever we design compiler, we need to go for expression tree. This is an expression how this thing is calculated. The value of a and b will be added and that value will be multiplied with c. So, this tree is called expression tree. So, whenever we are trying to perform some kind of operation using expression tree, so there we use this particular binary tree. Then comes another example, that is called data compression technique. In case of Huffman, there are different technologies are there. In Huffman coding, when through Huffman, wherever we are trying to compress the data, we will use this particular sequence. Say for example, how this Huffman coding works. This is a text file, this is a text file. Say for example, this is a text file, something is there, this is my pen, this is belongs to this is of red color or whatever. There are something which is written and some expression is there, some a, I am assuming there are basically there are three expressions like a, b, two different characters are there, two characters are there which is having this particular document, in this document only a, b, just say for example better understanding. So, if I want to compress this value, if I want to represent these numbers in our binary system, then what we will do? Either for a I will take 0, for b I will take 1. So, by 0 1 assuming that the whole text is written using a and b. So, what I will do? I will take two different values. So, where A is there I will replace A with 0, B with 1. If I have A, B, C, D, A, B, C, D, E. Now, I have how many values are there? 1, 2, 3, 4, 5. Now, tell me what are the different values that I will take for this. So, how many? So, if I have 1 bit, by 1 bit I can represent two different characters, because if I have 1 bit either 0 or 1, I can represent two different characters. If I have 2 bit, then I can represent two different characters, four different characters. If I have 3 bits, then I can represent 8 characters. Like how I can represent? By this I can represent 0 0, 0 1, 1 0 and 1 1 by help of 2 bits, by help of two different bits. I can, this is 1, this is 2, this is first, this is second. Okay. So, by this we can represent 4 different characters. If I have how many? If I have 3, 4, 5 different characters are there. How many characters are required? So, how many characters are required? We need some characters like this. We need, like for A I need 3 characters, 3 characters or 3 digits. For B I need, this is 0 0 0, this is 0 0 1, this is C, this is 0 1 0, this is D 0 1 1, and this way E, this is 1 0 0. So, this way we can represent, but it is very lengthy task, or it will very much I can say what problematic job. Why? Because look here, if I try to represent how many values in our text, if there are A is used 200 times, B used 90 times, C is used 30 times and E used 5 times. Now, what is the value? So, for 3 bit, how many bit is used? For 200 into 3 plus 90 times, this value used, that is 90 times what value? Again 3 digits is used. I am trying to calculate how many bits are used. Okay. Then how many times? This is 30 into 3 again, then 5 into 3 again. Now, if I have, this is the value, this is 600, 270 plus 90 plus 15. So, if you observe, this value is huge, this value is a huge value. Now, is there any better solution? Now, you will say, yes, if the character which is used more number of time, if I can minimize this value. So, how it is minimized? Yes, it can be minimized. So, we want to represent something like this way, we want to represent the thing, this thing like this way, we want to represent the thing in like this way. How we will represent the thing? We represent the thing like this way. This is our whole document. A is used 200 times. So, I am using A here 0. B is used, this is say for example, this is 0 1, or this way we will represent the values like A, this is B, then C and D and then E, then D, then E. For 1, this is 0 1, this is 0 1, this is 0 1, this is 0 1. Now, have a look. A is represented as 0, B is represented as, this is 1 0 0, B is represented as 1 0 0, 1 0 0, C is represented as 1 0 1, C is represented as 1 0 1, D is represented as 1 1 0, D is 1 1 0 and E is 1 1 1, E is 1 1 1. So, look here, this way for A is represented only using one digit. So, A is using only one digit, that is look here. So, A is using only one digit. So, this value we are this value definitely 200 into 1, that is only by help of 20 digit I can able to again do the same, minimize the number of bits to represent. So, this is the way how the value is compressed. So, definitely this value will be less, and with less number I can represent the same text. So, this is the way how the compression technique works. Another one is priority queue, and how the priority of the different process will be defined. So, there are two different priority queues, one is min heap and max heap. When I will discuss heap data structure, then I will discuss about them. Then in artificial intelligence, like decision tree, how, say for example, the weather, if it is cloudy, then go for this one, if it is then this, then it is a little bit rainy, then it is bit humidity is less, more. So, by help of these decisions we can able to represent the machine learning algorithm. That is one of the learning algorithm is the artificial decision tree in artificial intelligence. In machine learning we use this tree. There are so many amples of examples where we use this these data structures. Okay. So, these are the different applications and the structure of the binary tree. Okay, thank you for joining, and if you have any query, definitely write in the comment section so that I can improve myself, and at the same time I can go for more videos. Okay, thank you.